Okay.
Yeah.
Alright. Assalamualaikum and a very good evening to Dr. Liu and all my fellow classmates. Today we are from the group 21 Cool, and we are going to present about our project, which is the Mosaic Montage Workflow using HTCondor DAGMan and NFS. Next. So this is our team members. Consists of Farid Muhammad Salim, me myself Omar Abdul Aziz, Muhammad Rahmat Samsudin, and Syaku Putra. Next. So as for the overview of this project, we have decided on using the HTCondor cluster, using 3 VMs that are running on Amazon Linux, that was set up on the AWS EC2 servers. This setup also was created to run the M101 Mosaic Montage Workflow, where the output will be a 2 mosaic of M101 and their corresponding so-called the galaxy images. In this project, a linear DAGMan workflow and a parallelized DAGMan workflow were created and executed to measure the performance and efficiency of the workflow, to determine and to see which one is better and which one runs at a faster rate. Next. So this is the system architecture of our project. We are using, as I mentioned before, 3 VMs, where HTCondor Central Manager that acts as an NFS server, and we also have the HTCondor Execute that act as a worker, and the last VM we have the HTCondor Submit that act as a scheduler. Next, I will pass this presentation to Farid Muhammad Salim to further presentation.
So hi everyone. First, before I go into my explanation, let me run the workflow first because it takes some time to run the thing. Right. So first thing I'm going to do is I'm going to run the linear workflow first. Go into here, cd M101. Sorry. So now let's go to the parallel workflow. Does not produce an output that job F depends on. So we have branched out the workflow after job C to produce a parallel DAG workflow. All right, so now I'm going to show you the sample job file. So this is one of the job files that I've created. So it just contains the init directory, the universe, executable, arguments, the transfer input files, also the output log and error, and also queue. So this is basically the same template for almost all the job files in the workflow. Right. So the next one is the linear DAG file. So inside the linear DAG file, we have the job declarations and also the relationship between the parents and also the child. As the name implies, this is a linear DAG file, so the relationship is also linear. So we have A to B, B to C, and so on and so forth. And next we have the parallelized DAG file, in which I mentioned just now. The node branches off at node C. So we can see here, the parent C has 2 childs, which are D and F, and then from D it branches off to E, and F to G, and so on and so forth. All right, so from our test that we have conducted, we have discovered that the execution time for the linear DAG is around 2 minutes and 27 seconds. And for the parallel DAG is around 2 minutes and 17 seconds. So it shows a difference of 10 seconds between the parallel and also the linear DAG workflow. All right, so now I'm going to pass the presentation to Syaku and Rahman for the challenges and solutions.
Hello everyone, my name is Syaku. So I will present about the challenge and solution. So the problem one is same as like last group, which is initial we are run both, which is DAGMan and Pegasus. So we focus on split our team, pick up the 2 team. The first team is I and Rahmat, we do the Pegasus, and Farid and Omar, we do the DAGMan. But problem encounter at the process of the Pegasus, where as you can see down there, they are ready for 3,392 of the job because the M project not found and cannot run properly, and that's why a lot of jobs cannot be submitted. So solution, since that from the initial we have run both for DAGMan and Pegasus, so we will proceed on DAGMan, and we successfully run until the end. So that's why we are proceed with DAGMan. So next problem. So next problem is we are counter which unable to run project of input image. For example, like we are try to command M project exec, so output key will be appear. So the solution is we try another montage, which is a montage M101, and we try to implement a reproject, and we are successfully run, and now output of so example like key. So that's our solution, run another montage. Next, for the DAGMan application, it cannot be submitted. I don't know why, but we try to use setup manually by using network file system that installing NFS server in the server side and NFS client on the client side by using the method. So by doing the NFS manually, we can submit the job. So that's why we proceed with solution where using the network file system. So next, I will pass to Rahmat for the further presentation.
Okay, Assalamualaikum and good evening to Dr. Liu and fellow classmates. So for the next problem is this error occur when the machine is reading the file after we execute the job. So this is because the HTCondor execute on its own temporary directory, but we don't provide the full path of the directory. So what we have done to solve this issue is by export all the path on scheduler machine of montage directory to make sure the file needed is transferred to the execution directory before we execute the job. So for the next problem, so the next problem is we cannot execute the job because it is requires for us to access the final directory for the input-output operation. The error also occur when we try to generate a mosaic from the projected images and when we coding all the projected as smooth images to the final mosaic. So after study the problem, we figure out the solution for this problem by removing the final directory to output the grayscale mosaic images. So the JPEG mosaic images, the uncorrected and corrected feeds file will be created in the M101 main directory instead. So next, I will pass back to Farid for the demonstration.
Right, so let's check our machine to see if the job's done. So I'll just check the directory. Right, so we can see right now the workflow has been executed and we can already obtain the Mosaic GPG. So if you want to take a look, you can just go here, go here, go here, and then refresh this. And then where's the file? You can just drag it here. Or then let's just check if this works. I mean, if the output is correct. Montage jobs parallel. All right, let me refresh. Oh, sorry, that's the wrong directory. It's in this one. Okay. So yeah, as you can see, the Mosaic output has been produced by the workflow. So we can see that the workflow has been executed completely and without any problem. And if we want to, let's say, check the runtime of the workflow, we can just go to the run parallel.dag.log. And we can see that this is the time of the execution. So let's see, it started at 10:05 and ended at 2:02. So that's roughly around 1 minute and 57 seconds, if I'm not mistaken. Yeah, that's around that time for the parallel workflow. So let's check the the execution of the linear workflow by going here. And you can see that it has been executed completely too without any problem. And let's check the execution time. So yeah, as you can see, this is roughly around 2 minutes-ish. Yeah, that's around 2 minutes plus. So you can see that the parallel workflow runs faster than the linear DAG workflow. So with that, I think that wraps up our presentation. So I'll pass back the floor to Dr. Lee for any questions for our presentation.
All right, thank you. Okay, can you go back to the slide back?
Okay.
Up to your deck just now.
Is it this one?
Okay, hold on. Okay, hold on. Okay, so this is the linear. Okay, go down to the slide number 9, page 9. So basically, you just split the what's the name of the process?
I didn't remember the name.
The uncorrected to one workflow and the corrected to the other workflow, right?
Yeah, that's correct.
Okay,
like
okay,
this one.
understand.
Mm-hmm.
Yep. Okay, I'm good.
All right.
Thank you very much,
Okay,
guys.
thank you, Doctor. Thank you very much.
You're welcome. And last but not least, we have Gory.